All right, for this last example I'm going to do of dimensional analysis, this is another fairly long problem, and it's another one where we're going to have to convert units that are both in the numerator and the denominator, and it's another one where we have units to a power. So we've got kind of a lot of things combining together with this problem. Just like we did with one of the previous problems where we had compound units. I think there was a problem with density. Notice here that the original value we're being given, the 6.5 meters per second squared, has compound units. And so that is the value we're going to start with. And we need to know how to express that as a ratio. So recognize when you have compound units, the unit in the denominator can always be assumed to have a value of 1. So when we say it's 6.5 meters per second squared, it's per 1 second squared. So that is my starting point for this problem. Now I want to end up in units of miles per hour squared. So notice that both the numerator and the denominator are changing in this problem. And so that means I'm going to have two road maps, as we saw before when we had both a numerator and a denominator that were changing. So in terms of the roadmap for the numerator, I want to go from meters into miles. And so I'm going to start with meters. And what's the first thing I'm going to convert into? Well, I want to do that. I want to decide on that based off of what conversions I need to use to get into miles. So if you remember, when I come up top here, we've got two conversions that are dealt with for length. There's the 2.54 centimeters to 1 inch, and there's the 1 mile to every 1,760 yards. Now, it is important here to note that we're going from meters, which is a metric system unit, into miles, which is an English system unit. And the only conversion factor I give you for doing that is the 2.54 centimeters to 1 inch. So if we want to get into the metric system, we have to be in English, or we have to be in, if we want to get into the English system, because that's the goal here, we need to be in centimeters first, right? Because we're going to get into the English system by getting into units, or into inches. So my meters that I'm starting with here, I need to get that into centimeters so that I can use that conversion factor, which is going to allow me to get into the English system and into inches. Once I'm in inches, then I want to get to miles. And so this second conversion factor deals with yards into miles. So I need to get inches into yards before I can use it. So inches, the easiest way to get to yards for me is to go inches to feet first, and then from feet into yards. And so once I'm in yards, then I can finally use that conversion factor to get into miles. And so notice here, the numerator involves several steps to get from meters into miles if you're using the unit conversions that I'm giving you, as well as any that you have memorized. Now, obviously, again, this is a practice problem, so if you weren't using those strict rules for how to approach it, you could have just looked up the direct relationship between meters and miles and done that in one step. But if you want to give yourself the truest sort of experience of what this would be like on an exam, then I challenge you to only use the conversion factors I give you, or any that you would have memorized off the top of your head that you would know from grade school. For the denominator, we are starting with seconds squared, and we want to get into hours squared. This one doesn't really require any special conversion factors that need to be given to you up top, because all of you should probably know how seconds are eventually related to hours. In fact, some of you might even know that direct relationship off the top of your head. For me, I always like to go step by step. So I know I can take seconds squared into minutes squared based off the relationship between seconds and minutes. And once I'm in minutes squared, it's easy to get to hours squared based off the relationship between minutes and hours. And so we'll deal with the squared part of this in a second here. But for now, let's just recognize that if you know how seconds and minutes are related, and you know how minutes and hours are related, then those conversion factors are what we're going to use when we have a squared version of those units. So when I go to string this all together, I'm looking at, again, the number of, I'm looking at, again, the number of arrows that I have here, because that represents the number of conversion factors I'm going to need. So I've got 1, 2, 3, 4, 5 arrows for the numerator and 2 arrows for the denominator. So that's a total of 7 arrows, so 7 conversion factors. So I'm going to try to squeeze this all into one line here, but it's always fine if you want to do more than one line Just be careful that you don't round your values in between. Let's see, did I get up there yet? 1, 2, 3, 4, 5, 6, 7 at the end here. Okay, so keeping track of my units, I'm going to start with the numerator first. So meters into centimeters means I want meters on the bottom, centimeters on the top. Centimeters into inches, I want centimeters on the bottom and inches on the top. Inches into feet, I want inches on the bottom and feet on the top. Feet into yards, I want feet on the bottom and yards on the top. And then yards into miles, I want yards on the bottom and miles on the top. Again, making sure that all these units cancel out on top and bottom, leaving me with the unit that I want in the numerator. For the denominator, I want to get seconds into minutes. So I'm going to put seconds on the top and minutes on the bottom, because my seconds squared starts off on the bottom. That means that I'm actually putting seconds in the top this time. So the one that cancels out is actually in the top on when you're converting a denominator. I also need to square this whole thing because I want seconds squared to cancel out. And so my units need to be squared as well as the numbers that are inside this conversion factor. Same thing when I go from minutes into hours. Minutes are going to be on the top, hours are going to be on the bottom, and the whole thing needs to be squared so that minutes squared are going to cancel out. Notice that when I use this conversion factor here, I'm going to end up with minutes squared on the bottom because this square applies to both the numerator and the denominator. So that's why the minutes squared over here need to cancel out, and that's how we're going to end up with hours squared. So if I go through and make sure that I've got my units canceling out, seconds should cancel out, minutes should cancel out, and I'm going to be left with hours, and it's going to be squared. So I put in my numbers now. So the centimeters to meters relationship, you probably have memorized that there's 100 centimeters for every 1 meter, but if you don't, you can also use the prefix table for the metric system to figure out that relationship. For inches to centimeters, I need the conversion factor that was given to me up top here. So this is going to be the 2.54 centimeters equals 1 inch value. So 2.54 on the bottom and 1 inch on the top, keeping those numbers associated with the units that they were associated with in the equivalence statement. Feet into inches, you should know that there's 12 inches for every 1 foot. Feet into yards, you should know there's 3 feet for every yard. And then miles, to get that from yards, we need this last conversion factor up top here. So 1 mile equals 1,760 yards. So 1,760 yards and 1 mile. Then for the seconds and minutes, we are going to note that there are 60 seconds for every 1 minute, and that there are 60 minutes for every 1 hour. Notice that the number I put in there relates the seconds to the minutes. It's not the squared value because we're going to take care of the square when we go to punch it into our calculator. So going across here in your calculator, you're going to start with 6.5. You're going to multiply by 100. You're going to divide by 2.54, divide by 12, divide by 3, divide by 1,760, and then you're going to multiply by 60 squared, and then again by 60 squared. Right? And you can type that whole thing into your calculator in one long line if you want to, and I encourage that so you can avoid rounding errors. Coming down here, what we get from that calculation is 52,344, and my units, remember I pay attention to what I have left up top here that didn't cancel out. I should have miles on the top, and that hours on the bottom ends up squared. So it should be miles per hour squared. For sig figs, again, this is one of these situations where none of these conversion factors are going to affect the sig figs because they all have infinite sig figs. And that's either because they're exact numbers, or they come from the same unit system, or this weird one here that goes for inches to centimeters, we take those as exact numbers. So that one does not limit your sig figs. So your sig figs at the beginning were 2, so our sig figs at the end should be 2. And so that means that my final answer here is just 52,000 miles per hour squared, or you can express this in scientific notation, 5.2 times 10 to the 4th miles per hour squared. Either one is acceptable. Notice here, this is one of those numbers where it really doesn't matter whether you express it in standard notation or in scientific notation because it's about the same length no matter which way you express it. If you're wondering what the general rule is on when you need to use scientific notation, I will require scientific notation for the problems that are dealing with testing on it. So, we're early on in this semester, we're actually testing on scientific notation. And so if you're asked to express a number in scientific notation, then obviously you want to use scientific notation for the answer. But any other time, you can go based off of the length of the number. So if the number's not very long when you write it out in standard notation like this one, you can just leave it in standard notation and that's fine. If it's longer than this, if you've got a lot more zeros, then I expect you to convert that into scientific notation when you give your final answer. So usually that is anytime you have more than 5 digits. So when we're getting past 5 digits in the number, that's typically when scientific notation makes sense. But do keep in mind that the more sig figs you have in the number, the less likely scientific notation makes sense. Because you're going to have to include all those digits in the scientific notation anyways. So you're only going to make the number longer by adding the times 10 to the whatever to the end of the number. So it's a combination of how many digits do you have in the number and how many of those digits are significant in terms of whether you keep it in standard notation or whether you switch it to scientific notation. Honestly, though, for most free response type problems, like problems where you have to show your calculations, I'm not going to care that much how you choose to represent your final number as long as you make an effort to express it with the correct number of sig figs. And make sure that you include your units. Units are very crucial to make sure you include on any value that you report as a final answer.